My name Vivek Kumar Verma. I am an assistant professor in Department of Electrical and Electronics Engineering. Today I will discuss 8085 microprocessor. 8085 microprocessor is developed by Intel in year 1973. It is 8-bit general purpose processor. It means it can process 8-bit data at a time. It can address 64 kilobyte of memory through 16-bit address line. So in microprocessor, the number of memory locations that we can address depends upon the number of address line that we have in the microprocessor. For example, if we have a 16 address line, it means 2 raised 16, that is 65536, or we can say 64K. This much memory can be interfaced with the help of 8085 processor. It is having 40-pin IC. It requires 5-volt power supply. It can operate at 2 speed. In initial it can run at 3 megahertz, but later on it can also run at 5 megahertz. And its instruction is compatible with the older version, that was 8080. Any microprocessor can be represented by two models. One is called hardware model, another is called programming model. Hardware model means how many components it may have, and we must know these components before working with the microprocessor. And in programming model, we must know the various things within the processor which are required to program the processor. So if we talk about hardware model of 8085, then it is having accumulator, it is having ALU, that is called arithmetic logic unit, flag register, instruction decoder, register array, memory pointer registers. Along this, internally it has timing and control in it, means all the operations are controlled by, or we can say controlled by this timing and control unit, control and monitored by. And externally, all the memory, input output device, memory or input output device, they are connected through these three address bus, data bus, and control bus, these three buses. Now we talk about programming model of 8085. Programming model means we must know the information to program the processor. It requires that we must know how many registers the 8085 have. 8085 has 6 general purpose register, and these are B register, C register, D register, E register, H register, and L register. These are basically 8-bit register, and they can also combine to make a 16-bit register pair. And in register pair, they can be combined BC as a BC register pair. They can combine DE register pair. They can combine as HL register pair. It has also accumulator. This accumulator also work as a temporary storage, and sometimes it also act as a register for arithmetic and logical operation. Now, another information that are required to program your processor is flag register. Flag register, first of all, we must know what is flag register. As you all know that when we program in any language like C language, Java language, any language, so we require if C equal to 11, then this condition will be executed. else this condition will be executed. But internally they are conducted through this operation conducted through this flag register. So microprocessor, in 8085 microprocessor, we have five flag bits, and these five flag bits are called S bit, Z bit, AC, P, and carry. S bit also called sign flag, Z called zero flag, and AC is called auxiliary flag, and P is called parity flag, and CY is called a carry flag. Now, sign flag is a something by which he can know whether our result is negative or positive, because microprocessor doesn't understand the number is negative or positive. It can make a conclusion by the result. For example, if we doing any operation, not subtraction, we could doing any operation, and for example, we have one data and we have another data, and if we are doing addition, and if we are getting like bits like this 1 0 1 0 1, if this last bit is 1, it means sign flag equal to 1. This indicate our result is negative. If it is 0, then it means it is negative. Result is positive. And if it is 1, then it means result is negative. Okay. Now comes to zero flag. Zero flag basically indicate the result is 0. If you're doing any operation, subtraction, addition, multiplication, whatever you want to do operation, and if the whole result will be 0. For example, if we're doing addition, and if we are getting all the 8 bit in the result 0, it means your zero flag will be 1. This indicate your result is 0. In the same manner, the carry flag basically indicate the overflow from the 8th bit. 8th bit during any operation. For example, if we are doing addition of these two numbers, and if they generate a carry from this bit to like this, then carry flag will be 1. Okay. In 8085 microprocessor, there is no borrow flag for subtraction. So carry flag also used there as a borrow flag, and it is very helpful in subtraction also. Now, auxiliary flag, this flag is basically not available in the form of instruction, and it is used in decimal addition. For example, we all know that any microprocessor in the world only do a binary addition, binary subtraction. It doesn't know decimal things. So we can do decimal addition by some method, and auxiliary flag basically help in this method. How it can help? For example, if we have a number like this, and if there is a carry from D3 to D4, D3 bit to D4, then auxiliary carry flag is said to be 1. So whenever do any operation and there is a carry from D3 to D4, the auxiliary carry flag will be set. This auxiliary flag is used in decimal addition. Now, last bit that we'll see, that is flag with parity flag. Parity flag indicates whether the number of 1 in our result is even or odd. For example, if we got, so if we see the number of 1s, so the number of 1s are odd, then the parity flag will be 0. And if the number of 1 is even, then parity flag will be 1. So in microprocessor, there is no if and else section initially in 1973, 1974. So with the help of this flag, we can do all the condition-based programming. Now, along this, we have we must also know some knowledge of program counter or stack pointer. These are also registers, and they are help in accessing the programs. Program counter basically holds the address of the next instruction. For example, if we have an instruction MBI A comma 20H and it is written on this address 2000H. So program counter always hold. Program counter in short form it is indicated as PC. So it always holds the address of the next instruction. This instruction is of 2-byte instruction. So the next address will be 2002H. So program counter will be hold 2002H. Stack pointer basically holds the address of that location which are which holds the temporary address of the some data. For example, if you want to do programming to call some function, so in order to return back to the main program, the return address will be stored in the stack, and this stack starting address of this stack will be stored in the stack pointer. In short form, it is indicated by SP. So whenever we call a function, the return address will be stored in a stack, and the starting address of the stack will be stored in a stack pointer. Now we will see the architecture of 8085 microprocessor. In 8085 microprocessor, we already talk about registers we have like B register, C registers, D register, E register, H register, L register. They can combine as PC register and D register as well as HL registers. Along this, we have two memory pointers. These are called stack pointer and program counter. If we talk about ALU, ALU is an area where we perform arithmetic as well as logical operations. So whenever we do any operation with two data, the first data must always will be in the accumulator, and second data can be take from registers or can be take from memory through this data bus. Now, along this, we have a timing and control unit, which have clock circuit, clock circuit, ready pins, read bar signal, WR bar signal, ALE signal, S0, S1, IM bar, hold, HLD. These are all basically control signals that are required to control all the operation of the microprocessor. Along this, we have a interrupt circuit. We have a 5 interrupt. These interrupt are INTR, RST 5.5, RST 6.5, RST 7.5, and trap, in which trap is having a highest priority and INTR has a lowest priority. To do a serial communication with the outer world, we have a serial communication port to take a data serially inside the microprocessor. We have a SID, and to give the data outside the processor, we have a pin SOD. So this is a complete architecture of 8085. So microprocessor consists of basically ALU, control unit, instruction register, and decoder unit. This instruction register and decoder unit is a basically area where we will fetch the instruction from the memory, and this instruction will come to this area, and in this area first we decode the instruction what the instruction want to do. For example, if we want to decode the instruction add A comma B, so first it will fetch this instruction, and this is called opcode, and these are operands. So First, it will decode the this add opcode, and from this it come to know that it is an instruction of addition of two operands, which are A and B. So decoding and fetching instruction basically fetch the instruction from the memory and decode the instruction. So we have discussed ALU control unit, instruction register and decoder unit, register within the processor, interrupts, internal data bus. Thank you for today's lecture.